Is it working? Oh, looks like it is working. Cool. Man, if I am your greatest of all time, you have extremely low standards. Can you give me a hug, sir? No. Most definitely not. It's not really a face reveal when I've been on... Well, I guess it's like face reveal for YouTube, but like I've been in videos in the past. It's just like the room is such a mess that like it was like, oh, I should probably get a green screen if I want to have a face cam, because like there's just like piles of hardware behind me. Um, and yeah. And I didn't get a green screen, I just remembered that NVIDIA Broadcast exists, and I do have an NVIDIA GPU now, so, like, maybe I should try it. And so I tried it, and it's like, it's actually pretty good. So here we are. Yeah, no. Nope. Can I begin then? Yeah, like it's first comes first serve until somebody with a super chat comes in which case they get to go first. Let's see if I still know how to. Okay, that worked. Cool. So and of course we have another 5800X 3D. Why are there so many of these? It's not B-die though. What is this? This is KFC. This looks like a Kingston part number to me. Is that right? Where did you learn about all the RAM stuff? I just did like some reading documentation and a lot of testing. Anyway, so yeah, we've got a 5800X 3D or an X570S Aorus Elite AX. Oh, so that's one of the refresh boards from Gigabyte. 16.8.21.19. This is Hynix? That TRFC is too low to be Micron. And if it is a Kingston... Wait, yeah, this really looks like a Kingston. It is Kingston, isn't it? It's a good CPU Hynix DJR. Yeah, I mean, that's what it looks like to me, because that TRFC is entirely too low to be Micron. As well as the TRC. Anyway, yeah, so primaries look pretty standard Hynix primaries. TRDs 4.4 good. Oh, you do have gear down mode disabled, but you're at 2T. Okay. Which honestly, like in my experience, gear down mode versus like gear down mode on 1T and gear down mode off 2T, they perform basically the same in my experience, which is why I don't usually bother with like the only like gear down mode 1T, gear down mode off 1T is fastest, and the other two are kind of interchangeable. Like some people say one of them is faster than the other, but I've like maybe if you use something really, really sensitive to memory performance, like, but yeah, like I've never found it to be enough of a difference to care. Though in some scenarios, the 2T setup is like more stable than gear down mode, but usually only if you're pushing like very high speeds in 2-to-1 mode. Anyway, so yeah, so primaries are good, TRDs, TRD LT fall good, WTR is good, TWR good, TRFC good, SCLs are at 2, good. Yeah, there's pretty and it is dual rank, and you might want to, yeah, so you're going to want to like that 5 over here and the 7. You probably want to bump that down to 4 and 6, and that should work. Because, yeah, as it is right now, you're basically losing a little bit of bandwidth for dual rank settings. Anyway, let's go take a look at the next set of timings. Apparently some Micron Rev B, budget Micron Rev B, which is a bit weird because I'm not really aware of where you would get budget Micron Rev B. It's not super common as a memory chip as far as I know. On a Z690 board, and is this a non-K CPU? It's gotta be, right? Because otherwise, why would you be at 3500? Yeah, it's gotta be a non-K, right? 12700 KF. Why are you at 3500 then? Like, you have system agent voltage. Why aren't you running... Yeah, like, that doesn't... Why would you run 3500 if you, like, you have system agent voltage? Because usually the problem is, like, if you have non-K CPUs, you can't raise the system agent voltage, and then you just get stuck at, like, 3466 or, like, 3600, something like that. Sometimes my PC refuses to boot with 2 sticks. What clock are the 2 sticks running at? SA is at 1.35. Oh. Okay, so the board's probably just, like, not doing something right for Micron. Yeah, Micron support on Intel boards is kind of spotty, in my experience. Well, yeah, like, it is kind of spotty. Like, Rev E on Z390, like, doesn't really work properly on some BIOSes. And then, like, like, I've actually had pretty good experiences with Micron on Gigabyte boards, but yeah, I can't say I've run, and I haven't tried Micron on LGA 1700 Gigabyte boards, and I haven't tried it on Asus either, but, like, LGA 1200, I remember actually Micron having pretty good support, even though on, like, Z390 it was really horrible. I don't know if towards the end they might not have fixed that at some point, though. Anyway, so 16, 20, 16, which, yeah, that makes sense. TRS-36, yeah, because that's the funny thing with, like, AMD, you have the separate, like, TRC timing, but with Intel, you don't have a TRC setting. So the way you set TRC is through TRP and TRAS being set to the appropriate, like, TRC value. So so the TRAS being high makes sense. Command rate 2, yeah, I guess. WR at 20. I mean, WR isn't real on Intel CPUs, but I'm pretty sure that could be lower. Your, like, TWR pre setting could be lower. And then TRFC is... I'm pretty sure that's unnecessarily high, but when you have the refresh interval set to 32,000, it doesn't really matter. TRRDs are good. WTRs aren't. Yeah, no, the WRD, SG, and DG, those could go both... Yeah, those should both be able to go way lower. than where they are right now. RTP at 10, yeah, that's fine. I mean, it could probably go lower, but it's not really a big deal. TFAW at 16, good. TCWL 15, yeah, whatever. TCK 8, cool. And then I don't think you did anything with your tertiaries, did you? Because these just look auto to me, like 15, 16, 15. Yeah. The thing is, I'm not sure, but like I would definitely try to lower the. Okay, well, read to read different rank doesn't matter, but like read to write, I'd try to lower those, and I'd try to lower the write to read timings. Just SG, DG, the other ones don't matter. Yeah. Yeah, so that's my thoughts on that. And voltages, I don't, yeah, these don't seem to line up with anything, so I don't know. Oh, wait, DRAM we have at 1.45. Okay, makes sense. Um, Scroll back up and grab the next timings. Apparently, eighth. Oh, come on, YouTube. Why are you like this? Okay, how is it that some people manage to like give me links that I can't get to work, and some people are like it just works? Like what are you doing? Oh, okay, this one was like restricted for some reason. And I thought it was throwing out like I didn't read the message. I was like, this is just an error, and it's like, nope, it's like a content warning. Why is it a content warning? Apparently these timings are like not safe for work. Well, let's take a look at them. Anyway, so we've got a Z690 Tomahawk and commander, yeah, so 2T command rate again. Wait, is this? This is also Micron, isn't it? Yeah, because that TRFC is awful for. Wait, what? 2133. Oh no, that's actual frequency, not effective speed, right? Yeah, I think that's 4266. So this has to, yeah, this is, yeah, okay, this is Micron, because if this was Hynix, then it wouldn't be doing TRCD 19. I don't think. Um, anyway, so yeah, the primaries are very tight for Micron. Like, is this like one of those crucial 4400 TRCD 19 kits? Because like that's like that's the thing is like yeah, Micron like Crucial managed to bin the Micron chips into doing like TRCD 19 at 4400, which is absolutely insane. That like for any other manufacturer, that's a Samsung B-die bin, and then there's then there's Crucial. Um, but anyway, so yeah, so 4266 TRCD 19 and oh, that's a G skill. But same ICs as the 4419. Yeah, but like the thing is like I have Crucial kits that are like 3600 TRCD 18 and they wouldn't do 426619 TRCD. Um but anyway, yeah, so this is really tight on the primaries for Micron. And then 65,000 refresh interval, TWR at 16. I think that's higher than it probably needs to be, but it doesn't really matter that much. WTRs are 2 and 6, so very tight. TRDs at 4 and 6, so yep, that's good. 16 TFAW, RTP 8. And then we have 6, 4. Right. 6. Wait. Oh, right. 6, 4, 6, 4, and then 12, 12, and 26. Wait, where's the right to read? Oh, that's over here. 26 and 22. Cool. Yeah, so this is like the whoever posted this, you can use this as inspiration for like your tertiaries. Um so yeah, anyway, so this is really good. This is some really good Micron memory right here. Like, you don't really see a lot of Micron doing TRCD19 above 4000. I mean, we don't really get to see a lot of memory running above 4000 here in general, because, like, most of the submissions are 5800 X3Ds, but anyway, moving on to the next submission. Oh, it's another Ryzen system. Yes, it is. Imagine if Intel made good CPUs. These would be so much less boring. Anyway, oh my, why? Well, okay. Let's go through. No, I'm not, like, okay, I'll just use the freaking... Dude, these are neither... Why can't you just use Zen... Oh, wait, why is your Zen timings like that? Anyway, 3800, 1612, 1614, 32, 46... TRFC 460... Why is your T-Fall at 36? Do you hate performance? And it's TRX 40. Well, this is what you get for using freaking DRAM calculator, because it's like, yeah, use trash software, get trash timings. So anyway, wait, did you literally? Okay, no, you like. It is BDI. Yeah, use trash software, get trash settings. I just like. Anyway, so 16, 12, 16, I mean, I'm not really, like, the primaries, I don't really have a problem with that. But that T-fall right there, that just, no. No, absolutely hell no. That should be a 16. By having it set to 36, this is equivalent to what your TRRDs being like 8, basically. Wait, not even 8, it's like 9. Yeah, so that's horrendous. Your WTRs are fine, TWR is fine. Why your TRFC is at 460, I have no idea. Your SCLs should be at 4, if not lower. RTP6, okay. TCWL 16, fine. This is 64 gigs, so this is a dual rank setup. So you're going to want to set your dual... I'm not sure if Threadripper will do this, but you should probably set your, like, SD, like, read-to-read SD and read-to-read DD to 4.4, and then write-to-write SD and write-to-write DD to 6.6. Uninstall this garbage software from your system. This, like, why? Should be 4266. Yeah, no, I figured out that the MSI Dragon Ball is reading, like, actual frequency instead of effective speed. Oh, wait, I'm, like, way behind. Well, I guess I'm just gonna grab the next submission after the super chat. So, let's take a look at that. Got a 7950X. So this better not be horrible. Oh, it's 192 gigs of memory. I feel so sorry for you if you need 192 gigs of RAM. It's bad. And the worst part is like, I don't even... What even is this? Oh, it's Corsair. 48. This might be Micron. Like, I don't actually... Yeah, I don't know what it would be. Oh man, it's so bad. That's like a 10% refresh cycle. Your refresh interval is 10,000 and the refresh cycle is 1,000 clock cycles. This RAM literally spends 10% of its clock cycles not doing anything. That's just amazing. Okay. Anyway. So, what? Like, the thing is, I have like zero experience with Micron. And I'm not sure if they're like I'm not like I don't know if it's Micron, but the thing is it's like a low spec Corsair kit. So like it is probably Micron. Also that single rank readout is wrong, it's dual rank. Actually it's quad rank. Um I wouldn't try to raise the speed because I think that would not go well. I'm assuming if you have like such a large memory capacity, this is probably a workstation, so you'd probably benefit from memory bandwidth. In which case, bumping the FCLK higher would help. And shouldn't really be too difficult because your SoC voltage is low. And then, in terms of actual timings, I mean, I don't know what to do with the primaries because if it is Micron, like I don't know what it does. If it's Hynix, then you could probably do something like CL26 at like 1 point. Actually, yeah, at the voltage that it's already at, it could probably do like CL26 or something. Because you're at 5200. Let me just pull up a calculator. There's like a pretty generic speed, like 6000 and like CL30, right? Works really easy. So, yeah, I mean, we can just divide by 3 and then multiply it by 5 point. Yeah, because 52 is, yeah, so CL26 actually would work. Almost, well, yeah, if this is Hynix, well, maybe you'd have to bump the VDD to like 1.35 or something, so maybe not CL26, but like CL30 should basically work. Even if it's Micron, it should probably do CL30. I don't think the Micron memory chips even scale with voltage. That's like why they're so bad. So yeah, like the primary time, like cast latency should be able to go a lot lower than it is right now. This is one thing that I've always wondered about with like low spec DDR kits is like it doesn't make sense to have them because this isn't a JEDEC spec as far as I know for like there's the JEDEC specs are like 4800 CL40 and 5200 I think is like CL42 or something. Like there isn't a CL38 spec as JEDEC. And also JEDEC spec would be at 1.1 volts, not 1.25. So like I've never understood why you have like these low end kits where they just like run timings that are like way looser than they need to be. Even though it's like basic, like it's not like I don't imagine it would cause any like issues with just lowering the cast latency by like 6 cycles or something. Not that it would massively change the performance, but like you get like 6000 CL30 36, right? Like you have all these like as you go up in speeds, you get all these bins where like the timings are just all over the place. Like they're really playing with the memory timings. And then when you get to the low spec kits is like these are all just like it's just a 38 for all of the primaries and it's like why? But yeah, so cast latency could almost certainly go lower. TRCD, like honestly, I would not be surprised if this could actually run something like 30, 34, 34, 34, maybe even better than that. If it's Hynix, you might be able to do like 26, 30 for your primaries, but it's probably not Hynix. So if it's not Hynix, but you might still be able to do like 28, 30, 34, something like that. So you could definitely lower the primaries. TRC, I would definitely. I don't know how Micron does on TRC, but at 127, that's not great. TRDs, I would obviously try to get both of those to at least 8.8 and TFAW to 32. TRDL at 13. Honestly, I don't think Micron needs that, especially not at 5200. Like, there's Micron kits all the way up to like 7000. So yeah, I would definitely try 8832. WTRs, honestly, like you're at such a low frequency because that's the funny thing is if you're at a very low speed, doing low timings is actually really easy. But I'm not sure how Micron does with WTRs. TWR, I would imagine, can just be at 48. Like, I don't... Yeah, like, I would just try set that to 48. I can't see a reason why that wouldn't work. Now, TRFC, I am not sure about. I have no idea what you'd have to do with TRFC, but I would probably just try... Well, you know what? No, I wouldn't touch TRFC first. I'd first raise refresh interval to, like, 40,000. Like, if your memory sticks are running hot, I'd probably start with, like, 40,000 refresh interval. But if you have good cooling on the memory sticks, I would honestly go all the way to 65,000 refresh interval. I don't see any reason to not just max it out. SCLs, honestly, I would try set both the read-to-read SCL and write-to-write. I'd try to set both of them to 4. At 5200, they might even work at 2 or 1. Yeah, RTP, I'd probably try lowering that to 12 or something. TRDWR, like, you could honestly probably, you could probably run, like, the easy Hynix timings. And then the different rank timings, like SD, DD, I'd probably go, like, I'd start with, like, 8, like 8s for all of them. I think the right ones would go worse. This might go down to, like, 4455 or, like, 5566 or something like that, is my guess. Because you're at such a low speed. And I would imagine, like, 6688 would be absolutely not an issue for this to run. So, yeah, I wouldn't try to raise the speed because when you have this much memory, like, it like, the memory controller just doesn't, like, the speed is difficult. Because speed is basically about the memory controller's ability to, like, reliably read what the memory is sending and then, like, reliably send to the memory. And so when you have a lot of memory sticks, you just have a lot of endpoints, basically, on the connection. And that makes things difficult. But... So, like, speed in, like, a quad rank setup, yeah, that's hard. But the timings are internal to the memory chip. They don't, you know, like, if it runs 5200 at trash timings, it'll run 5200 at good timings, basically. Now, there are certain scenarios where that doesn't apply, but generally speaking, if you're not doing anything crazy, you don't need trash timings if you're at trash speed. Even if you're on, like, quad rank, like, you could run good timings just at garbage frequency. So, yeah, there's definitely a lot of, like, there's definitely a lot of things that could be improved. The biggest performance uplift for this would definitely be just adjusting the TREFI upwards. And then just doing everything else. Like, I wouldn't really concern myself with the TRFC, though. Like, tuning that shouldn't be too much of a problem. Like, I'd be surprised if you couldn't set it to at least, like, 700 or something. Anyway, next super chat. No, it's not a 5800X3D, but it is a Ryzen CPU again. Anyway, so we have a 3600 twice? Why? Oh, needs more testing. Cool. Okay, let's go through this. So, 3600 on a B450 Gaming Plus. Running 3733 on 16 gigs. Okay, so single rank, and we've got 1616, 1919. So this is some kind of Hynix. Yeah, it's G-Skill, so it's probably Hynix. So yeah, 1616, 1919, 3554. Cool, that makes sense. 4616, good. WTRs 4 and 12. I'm pretty sure Hynix can do lower WTRL than 12, like 8 or something. You have it at 10 too. Yeah, you could probably lower that to 8. Anyway, TWR 12, that could probably be lower. TRFC 489, that... You're at 3730. There might be... No, I think that's actually probably pretty close to the limit. SCL's 44. Cool. Though that... You might be able to run 2.2, especially since, like, over here you have... Like, the fact that SCL2, like, WR SCL2 boots at all... makes me think that you should be able to run read at 2 as well. I might be wrong about that, but I'm pretty sure, like, you could try it. Like, I don't, like, The SCLs, in my experience, will usually either work or not work at all. They don't tend to cause too many like hard to catch instability issues because you do a lot of those operations back to back, just like running the system at all. Um, so yeah, so usually if there's a problem with those, it's like very like it shows up basically instantly. Anyway, other than that, much lower TRAS, much lower TRC. This might be a problem for stability, the TRC. Um, yeah. But the rest of it, like, this looks fine. Yeah, because it is a single rank setup, so yeah, I don't, like, you don't have to worry about the dual rank timings. So, yeah, that looks cool. Next submission. And another Ryzen system. I'm really bad at copy pasting, apparently. We got a 5900X and it's running 3733 on a Crosshair 6 Hero. Now, that is an interesting pairing of motherboard. Yeah, because that's an X370 board, isn't it? Yeah, so 5900X on a Crosshair 6 Hero, and we've got 3733, 14, 8, 15, 14, 21, 38. So really, yeah, like really tight primaries. 4, 4, 16, 4, 8, 12. The TWR could probably go a bit lower, but it like doesn't matter at this point. Like, it's just not going to make a difference. TRFC 228. I was absolutely slammed on the TRFC. Then SCL's at 4.2, so I'm surprised that you can't run 2.2. Anyway, TCWL12, yeah, that makes sense. RTP6, TRDWR10, yeah, all good. And your dual rank timings are tightened up as well, so nothing to complain about there. And then I think you mentioned that, like, what was it, 1900 FCLK and or higher doesn't work. In my experience, the only thing that really helps with that is, like, fiddling with the VDDG voltages. And usually, like for 1900 FCLK, I've usually used like 1.1 SOC or higher, and then the VDDG voltage is approaching like 1 volt. But if I remember one of them, if you set one of them too high, it actually causes like random lockups, if I remember correctly. I think it's CCD, that if you like set the CCD voltage too high, it actually causes problems, but you want like relatively high IO die voltage for high FCLK. Also, these sticks don't seem to be particularly amazing considering the VDIM is at 1.57. I don't know that I would really put a lot of time into trying to get 1900 FCLK to work when like this is already really fast, and a couple more megahertz of FCLK is just not really going to make that much of a difference. So next submission. Got a 5800X at 3733 with what looks like Hynix, actually Micron probably, because that TRFC is pretty high. What is up with those SCLs? Like, why is right like higher? That doesn't like. I've not run a ton of Micron, but that is surprising to me. Oh, Corsair. Yeah, so this is going to be Micron probably. 3733 on a 5800X. That is a lot of latency. Oh, right, yeah, because like 16, 19, 19, 38, 57. Yeah, that makes sense. Wait. I feel like this should be somewhere in the 60s, not over 70. This is like 2 to 1 mode level latency. You have a bunch of like garbage running in the background. Because that doesn't... Yeah, because this is, like, surprisingly bad. Across the board, actually. But the timing's, like, I can't see anything immediately, like, super wrong with them. So I don't get, like, why, like, your IDA is so bad. Unless you have, like, a bunch of RGB garbage in the background or something. Yeah, because, like, the primaries, like, for Micron, they make sense. Then TRRDs are fine, WTRs are fine. I mean, for Micron, they can go lower, but that's not going to affect the IDA latency. TRFC, like, I don't think you can really set it any lower on Micron. And then, like, all of your back-to-back timings, like, those only really affect memory bandwidth. And, I mean, your memory bandwidth is not good. But, like, I don't think it should be this bad because of your tertiaries. So I'm going to go with your IDA results are terrible because there's a bunch of garbage running in the background. Wait, you're on Windows 11. Okay, that might be why it's so bad. Yeah, I just noticed the rounded corners, and it's like, oh well, that would potentially explain why IDA's so bad. Because like I've seen I mean, I've not used Windows 11 myself yet, but I've run into a weird number of occurrences of people complaining about performance, and then me asking like, hey, are you on Windows 11? And then like, have you tried Windows 10? And then it's like they try Windows 10, and it's like usually it's been like stuttering issues where it's like you go from 11, like you have stuttering on 11, you go to 10, and it's fine. Um, and I guess like 11 is just bad for performance or something. Um, it's all the advertisements they're injecting everywhere, slowing down the computer. So anyway, yeah, let's move on to the next submissions because I really think like this to me looks like a software problem. This doesn't look like a timing problem. This just looks like either it's Windows itself is bad or you have a bunch of garbage running in the background, which, you know, with Windows 11 may very well be just the OS itself being a bunch of garbage. Um, Memory isolation may have caused memory latency to increase. Yeah, I guess that could do it. Um, Anyway, so we have a Lin pack and then, ooh, a Z790 Aorus Master X. Not something you see very often. Running 7400. Hey, this roughly matches my experience with the refresh boards. And more 7400. Because, yeah, when the QVL says DDR5 8000, actually Gigabyte's QVL for that board says 8266. You subtract 800 before you get the real capabilities of the motherboard. Kind of funny. It used to be that within the DDR4 days, no, you would subtract like 10%, and DDR5 8000 minus 10% is 7200. So actually, yeah, the QVL is off by 10%. That seems to be pretty consistent. Anyway, we've got 7400, 36, 44, 56, 2, 48. So primaries look good. I'm a bit surprised that you're not running lower TRAS, but I'm guessing you like ran a bunch of benchmarks and came to the conclusion that 56 is best, and I'm not gonna like argue with that. Like I've tried doing a bunch of testing on like TRAS as low as it goes, TRAS kind of high, TRAS really high, And I couldn't really find a difference in any of the benchmarks that I care about. So it was like, okay, I'm just going to keep setting it as low as it goes. Um, but yeah, like if you have like if whatever benchmark you have prefers TRAS at whatever setting you have it at, then like I'm not going to argue with that. Um, so anyway, write recovery at 48. Yeah, what you can run that lower on Hynix if you're on Intel. Like the 48, that's like a limitation of the AMD memory controller. Um, anyway, TRFC2 at 650, TRFC per bank, right? These are 24 gig DIMMs. 450, yeah, so that's good. TRRDL at 12, yeah, that makes sense. 8, cool. TFAL 32, cool. WTRs, wait, you're at 64 and 48. At 7400, I think you can actually push them quite a bit lower, but I don't think, like, you might, well, I don't think it'll change performance that much at this point. Refresh interval, you're at 65,000, that's cool. And then read to read same group 14 and write to write same group 14 as well. Cool. Yeah, this looks good. I don't see anything to complain about here. What was in the other screenshot? Oh, that was just like the latency and detail. Yeah, I don't see anything that I would really change about this. Okay, I didn't miss anything. So let's move on to the next submission. And I'm gonna clean up my tabs a bit. So, what do we have here? The 7800X 3D running DDR5 6400, and any lower than 1.3 SoC won't run. Well, yeah, that's how that works. Like, if you win the Silicon Lottery with a 7000 series, it'll run 6400 at 1.3 SoC. And if you get an average CPU, it won't run 6400 at all. So, yeah, that is not even remotely surprising. So that's kind of that. It's just like, yeah, if you want to run DDR5 6400, you better hope that your CPU does it at 1.3, or like if you get really lucky, there are chips that'll do it at less than 1.3, but most chips, even at 1.3 SoC, won't run 6400. So like that's just, that's like that's that. There's not really anything more to it than that. Because as far as I know, it's basically just a limitation of like the UCLK needs a lot of voltage to reach certain frequencies. And if your chip needs 1.3 volts to run 3200 megahertz UCLK, well, you can't do anything about that. Anyway, man, this is really blurry for some reason. Anyway, we've got 32, 40, 40, 40. Okay, but those primaries could probably be tighter. But it won't really make that much of a difference. TRC 68, 48 on the TRDs, 16 TFAL. You're on a Asus board. Okay, that explains the 16 TFAL. That's cool. WTR's at 616. Cool. Wait, this is just my lazy timings, but you like tweak the TRFC to 420 instead of 500. And then SEL's at 44. RTP at 12. Cool. TRDWR 14. It's kind of surprising seeing that DWR up at 6400. And then this is a dual rank setup. And your dual rank timings are like backwards, which is weird. Usually, oh wait, no, I think it does do that by default, doesn't it? Where it like sets the read to read dual rank timings worse than the write to write, even though if you actually tighten them to the limit, the write to write timings are worse than the read to read timings. Anyway, so yeah, you're basically losing a bunch of memory bandwidth if you don't tighten the read to read like the SDDD timings from 11, like right now you have 11, 11, 9, 9. You want to set that to like 6, 6, 8, 8. And that should work. But if you're right on the edge of stability at 6400, it might not. You might have to lower the speed to run 6688. I mean, you could also try 8888, like 8s for all of the SDDD timings. Yeah, other than that, like, it looks good, though, otherwise. So, yeah, next submission. We have a 7800X 3D running 6200 on a X670E Tomahawk, and okay, like at 6200 you can definitely run TRCD lower than this. This is just my lazy timings for Ryzen again. Like, why do you submit these things, people? It's like, yep, you have followed the video correctly. Good job. Anyway. No, but like really, why do you submit these? Like what value am I providing by looking at like what I already gave you? Um but anyway, yeah, so 32, 40, 40, 40. Like yeah, you could tighten the primaries. Not that it's going to like massively change performance, but like if you want to do something, you could do that. Because I would imagine even at like 1.36 VDD, you could probably run TRC-DRD at like the TRCDs could probably be like 39 or 38. That doesn't usually require a ton of voltage. And then all of the other timings, like it's literally just like my easy Hynix timings. Like, what am I supposed to say? Um, yeah, I'm like you followed the video correctly. I hope you're happy with that reaction on my part. So anyway, let's next submission. And I clicked on the super chat, which was a mistake. Oh no. YouTube, why are you like this? There's like a pop-up that comes up every time I like, like I'm trying to highlight the link and yeah. Hey, got it working. These aren't timings. Why would what? The hell am I supposed to react to here? WSL Windows something. Oh, wait, is this a continuation of one of the earlier ones? Oh, yeah, okay, this is that Micron setup. Yeah, that latency makes a lot more sense. Yeah, so you did have garbage running in the background. Good to know. Also, thanks, Sisak PL for the £5. Um, oh, and then you actually posted the link separately. Cool. I thought it was just a super chat, but no, he had a link. And that link is breaking for me for some reason. Why? Oh, well, that one was my fault. That didn't work. And it doesn't load. Yep, that just doesn't load, and I don't know why. Yeah, I know, I saw this empty, like, I caught the fact that your super chat is empty, but the link you dropped is, like, not working for me. Try, like, make a new one. Oh, there we go, now it works. Cool. So we've got a 7700X. Oh, you are really smashing the memory voltage there. So yeah, 7700X on a B650M Aorus Elite AX running 6400 at 1.26 SoC. So this is a pretty, like, this is a good CPU in my opinion. And then, yeah, 28, 37, 37. So the CL28 at 6400, that's why the voltage is so high. And, like, it's not, like, this doesn't really make, like, a big difference in terms of performance, but, like, I don't see anything wrong with doing this. I don't think you're going to break the memory sticks. So, yeah. But, like, yeah. Like, from a, like, the point I'm trying to make is, like, look, if you want to run, like, safer settings, uh, you're not really giving up a lot of performance by like staying at like 1.4 volts VDD or something. This is more like, you know, if you want to like if you just want to like it's kind of just for fun in my opinion running like high voltage high memory voltages on Ryzen CPUs in my opinion for getting like low CAS latency working is more of a just for fun thing than like, oh, this really makes my performance so much better. Um because it really doesn't make much of a difference. And CAS latency is literally the only timing that really scales past like 1.4 volts. You basically hit minimum TRCD at like 1.4. Actually, maybe on I think most kits it happens below 1.4 even that your TRCD stops getting better. Um, so yeah. Anyway, 28, 37, 37, 33. So this is going to be Hynix 16 gigabit A die. So yeah, TRP 33, TRAS 30, TRC 63, TRDs 4.8, so absolutely slammed. TFAW at 20, so yeah, that's all minimized. WTRs at 2 and 16, so also, yeah, that was basically minimized. TWR 48, so that's on the register limit. TRFC at 450, very low, and then SCLs at 6 and 2. Interesting. I think this is like a thing when you get up to like 6400 that like sometimes you have to run relatively loose read to read SCL because this isn't the first time I've seen this. Anyway, RTP at 12, TRD WR 16, and WRD at 2. And this is not a dual rank setup, so we don't have to worry about the dual rank timings and refresh interval completely maxed out. Yeah, this looks good. There's nothing I would change about this. So, let's move on to the next submission. And we've got a not stable one. I really hope it's not Intel, because if it is Intel, I can't help you. Oh, it's Ryzen. A gene at 8000, and it's not stable. That is interesting. I'm gonna guess that you probably need more VDDIO. Because that is like a thing with Asus boards. That they tend to like pretty high VDDIO. So that's what, yeah, I would basically try setting like I would try raising both VDDQ and VDDIO to 1.4. To try get this stable as like a first step. It doesn't crash in game. Well, I'm not too surprised that it doesn't crash in game, but like personally, like it depends. Like here's the thing: if it's just a gaming PC, right, then you really like wouldn't have to care. But like for my personal system, it's like, yeah, you know, I don't like it would be kind of awkward if I crashed out of my own live streams, which I did used to do in the past when I was just like my daily system is generally built out of what I consider spare parts. So stuff that I have that I don't have any immediate like content plans for. And in the past that usually meant junk parts that were not good, like really garbage B-die and just the worst memory kit. And before that, it was like the worst memory kit that I owned. And, you know, like, so a lot of the time my daily system was not really that stable. Also, I didn't necessarily bother to stress test it properly all of the time. So, yeah, but I've kind of gotten sick of that. So, Yeah, these days I do prefer to have like more like it basically matters like how much do you value like your file system integrity is the way to look at it in my opinion. Because that's like and also like, you know, are you doing anything where crashing out of it is really unacceptable. Um because like yeah, you like, you know, if you want to run unstable overclocks and you're like fine that your system like sometimes just resets itself or whatever, that's cool, right? But um like you have to make the like you have to sort of decide that yeah, I'm cool with it being like that. And if you decide that actually no, I want a system that is as stable as possible, then you're going to go through that, you know, intensive stress testing process where you run LinPack, you run YCruncher, you run maybe even Prime 95. I personally don't usually use Prime 95 because that's where I sort of draw like Prime 95 small FFTs for CPU stability. This isn't like a memory stability test. Is very special because you can manually fine tune it to get the CPU running as hot as physically possible. Um, and there's basically no other workload that is as heavy as a like manually tuned Prime 95 small FFTs. So I personally like don't bother with like test validating stability for that. And if you just use the default preset for small FFTs, it like goes through a bunch of different FFT sizes, so it will eventually hit that optimal FFT size, um, where it hits like maximum heat output. But yeah, you know, so if you and then if one of those stress test crashes, well, you just have to, you know, tune until it stops crashing. That's kind of how that works, right? But yeah, I think for this, my immediate guess would be like probably just more VDDIO with and VDDQ. That would be the two voltages I would play with to try get this stable. Because that's usually I think the focus with the Asus boards. Um, and then SCLs, I mean, I had 9.8. I'd prefer that to be 8.8, but I don't think that's the end of the world. Like performance wise, that doesn't really make much of a difference. And then the rest of the timings actually look okay to me. Um, 8, 12, 32, 4. Yeah, like I don't think that I would really change anything else here. Just mess around with VDDQ and IO. Anyway, next super chat, which apparently is just $10 and no submission. So thanks, Scott Johnson, for that. I guess, unless you wanted to submit something and botched the submission. These 8,000 timings are atrocious. I mean, the cast latency could be lower, but other than that, like, yeah, the TRCD, this is 24 gig DIMMs. Like, that TRCD is not going to go much lower. It'll do like 46 or something. And then everything else, like TRRDS, like, this is 24 gig DIMMs. Like, this is not getting lower. TRFC might go a bit lower, but that's just not going to make a difference. It's not going to go below like I don't think it does 600 at 8,000, so it's like not going to get much better than this. So, anyway, next submission. Another 5800X3D. Man. With generic B-die timings. Okay, well, here we go. Generic B-die timings on a 5800X3D, though it is a B450 Tomahawk and a bunch of Viper Steels. Mismatched Viper Steels at that. TRFC is a bit high. I don't remember the, like, nanosecond numbers for the various memory chips. For TRFC. And it's not going to, like, drastically change the performance. Why are people OCing X3D? I mean, if you have a CPU and it can overclock, why wouldn't you? Right? Like that's the thing is like I have an ECLK overclock on my 7800X3D and it hasn't broken again yet. So maybe Gigabyte finally fixed the BIOS. Yay. And like the memory's overclocked on my 7800X3D and if you ask me why, it's like, well, I can. And I've also been considering putting a much more impractical memory setup in my daily system because I can. Um, Not because it like makes sense or anything. Um, so anyway, so yeah, 5800X3D, 3800, 16.8, 1516. That is a weird set of primaries right there, with TRP being higher than TRCD. Usually it's the other way around. Um, yeah, usually TRP goes below TRCD. But that like B-die in terms of silicon behavior is just absolutely all over the place, so I'm not even gonna question it. Like, sure, your TRP doesn't go below TRCD. TRS-21, TRC-37. I wonder if that TRP is where it is because of the TRC. In which case, I would actually trade TRS for TRP. Like, if like 1522 also works, then I would go with that. And if like 1423 works, I'd go with that. Anyway, it shouldn't, like, on Ryzen, that shouldn't really matter. As long as, like, your TRC isn't too low, you should be able to set whatever TRP you like. But, yeah. Anyway, moving on. TRDs 4416, good. WTRs 37, yeah, so that's about as low as those get on B-die. TWR12, cool. TRFC at 270, good. SCLs at 22, cool. And RTP6, TRDWR8. Yeah, this is really tight. And then also you have the dual rank timings set up properly. So, yeah, this is just a good dual rank setup. I'm kind of surprised that you're getting 3800 working on a B450 Tomahawk though, because I have a B450 MSI board, and with like 4x8 B-die, it was really difficult to get above, I think, 3666 or something. Then again, that was I tested that ages and ages ago, so like the BIOS might have gotten better over time or something. Um, so I guess the next submission, which I guess I'm gonna try to go in order instead of just grabbing the latest thing. So we have, of course, oh, we don't have a 5800X3D. Just saw like Ryzen timings and it's like, oh, it's not, nope, it's a 2600X running 3533, 1213. Man, for 2000 series, this is flying. I mean, it is single rank, so that explains some of the frequency, but like that, yeah, that is good. So 12, 8, 13, 11, 21. So this has to be running some pretty high memory voltage. Do we have a voltage readout somewhere? No. 3533 CL12. This is going to be like 1.7 volts or something. Unless these sticks are like miracle grade. Yeah, this has got to be like 1.7 or something. You're running really quite low SoC voltage for this. That's kind of surprising. Yeah, so 12, 8, 13. Yeah, so like the primary is that low. This has to be like 1.7 or something. 1.65 at a minimum. TRC at 32. So yeah, like the primaries are absolutely slammed. TRDs SNL 44, TFAW 16, cool. WTRs 3 and 8, cool. TWR 10, cool. TRFC 220, SCLs at 2.2, and then TCWL. I am surprised that you didn't. Oh, I guess you're pushing TRDWR as low as it goes. 6.1. Man. Yeah, this is pretty wild, and it ran 10 hours of test mem 5. Oh boy. Man, what voltage is this at? Because I really want to know. Like, is this because I think this has to be like 1.7. It can't really be more than like 1.75 because if it's above 1.75, yeah, like he didn't max mem the memory. Like he has all of the memory still available. So this can't be more than 1.75 because above 1.75, you basically can't use most of a B-die memory stick. Um, so like you wouldn't be able, like you wouldn't have 14 gigs of memory available. Um, Oh, well, we have another super chat in, so I guess we'll take a look at that. Is 1.66. Ah, yeah, okay, that makes sense. Still really like strong memory kit for 3533 at 12. Yeah, I think so. Like there's I'm pretty sure there are kits that need more voltage. Well, no, 3533. Well, the thing is, like, there's so much variance with B-die that I'm sure if you went through enough B-die, you would eventually find a kit that needs like 1.8 to do 353312, or it doesn't do 353312 at all. That's also an option. Um, anyway, so next submission, another Ryzen system, and another 7800X3D on an X670E Carbon running 6400 CL26 with 2200 FCLK at 1.15 SoC. What? Is that a reading error? I mean, he only ran Karhu for an hour, so this isn't exactly stress tested to the limits, but what? How is this working? There's no way that SoC reading is correct. Running 1.15 for 10 months at 6400. This could probably boot like above 6600. Have you tried to see what the highest UCLK that this'll boot is? This might boot like 6800. Like at 1.3, I think this would boot 6800. If we were on one of the old BIOSes that let you, like if you bypass the SoC voltage limit, I bet it would boot 6800 if you fed it like 1.35 or something. 6600, 2200. No, I was thinking like 60, like you don't need to keep the FCLK synced. Like I'm just wondering what the UCLK limit is. Because the thing is like 2200 FCLK, yeah, if you raise the SoC voltage, the FCLK gets worse. But the UCLK scales like basically, well, it's not linear. It's very non-linear. You need a ton of SoC voltage towards the top end of the frequency range. But like, I like it does one point like it does like my. I'm trying to think. Like this definitely boots 6600. It like the FCLK, like I'm thinking like 2000 FCLK. This would probably maybe do like 66, like 6700 might be bootable on a chip like this. Um, that's insane. That's like absolutely insane. I kind of want the CPU. I don't bin like chips at all, but man, like because the thing, like, that's the thing with binning is like, yeah, if you go through enough CPUs, you'll find something that like this, and it's just like, yeah, but I don't even want to like the amount of effort it would take to find a chip like this, unless you get really, really, really lucky, which I don't. Um, Like my luck with silicon, especially anything modern, is that like I'm lucky if it doesn't just die spontaneously or doesn't turn out to be defective from the factory. um anyway, um yeah, let's take a look at these timings then. 6400, 26, 37, 37, 32. So yeah, primaries are slammed. TRAS 30. Why is your TRC at 66? Like that should be at 62. 4816 cool, 214 cool, 48. Man, this is 48 gig DIMMs. Yeah, this is really dialed in. TRFC at 520, SCL oh, interesting. 5. Right to write at 1. Yeah, that's a thing that like works for some reason. With AMD CPUs. I kind of suspect it's because they don't use that timing. Anyway, RTP12 and TRDWR14. Yeah, so this is like in terms of timings, this is absolutely dialed. And of course, like, yeah, to get CL26 working at 6400, you need a ton of memory voltage. So the MVDD is at 1.7. But man, I can't believe you have a memory like this that it runs 6400 at 1.15 SoC. I actually just cannot believe. That's just like there are CPUs where with 1.3 SoC, it won't even post. And like the 7800X3D in my daily system is one of them. My daily system 7800X3D doesn't even do 6200, and then there's CPUs like this out there. This is an absolutely just insane chip. This has to be in like the top 1% of memory controllers that AMD has produced. Maybe less than top 1%. Anyway, so next submission. What, that 1.7 VDD is burning? Nah, if you point a fan at the memory sticks, it's fine. I actually stress tested for like 24 hours at 1.75 VDD. I wanted to, like, in my experience, once you go past like 1.75, the stability tends to get worse, but that might depend on what memory sticks you have. Mine does 6400, 1.15, 6600 boots and runs with 1.2. Booted 6700. Have you tried booting 6800 at 1.3? If you can boot 6700... Wait, is that 6700 with 1.3? Why is he not running 8000? He's on a 4 dimmer. That's why. Like, that's the thing, is does your motherboard have too many DIMM slots? Well, good luck. Anyway, so I'll grab a submission at random, I guess. How long have I been streaming? An hour. Okay, I don't want to... I think the last one was 3 hours. This time I definitely want to finish at around 2 hours. So get your submissions in, because you only have like 40 minutes. Anyway, let's take a look at this. So, hey, it's not an AMD CPU, but it's a Z390 system. On a Z390 Gaming Pro Carbon, 16 gig DIMMs, not B-die. What is this? Micron. Dual rank? Yes. That is surprising that it works at 4000. Actually, it's an MSI board, so that's not that surprising. MSI, at least on Z390 in my experience, had by far the best compatibility with various memory chips. Like on Gigabyte, if you put Micron sticks, you'd get stuck at like 3600. You put Micron sticks in EVGA, you'd get stuck at 3600. You put Micron sticks in Asus, you get stuck at 3600. You put the same Micron sticks into an MSI board, and you can do like 4,000 plus because MSI like actually optimized the BIOS to boot things that aren't Samsung B die. But the other manufacturers just like, what? Micron makes memory chips? That's a thing. So I think the Micron sticks were always just subject to like the default memory controller tuning, or just like the tuning for the B die sticks, and it just didn't work above 3600 basically. Um, Anyway, so yeah, 4,000, 15, 20, 20, 37. Yep, that makes sense. Because with Micron on Intel, like your TRAS and TRP are setting your TRC, so you can't run, like a lot of the time on AMD, you'll see like really low TRAS, even with Micron sticks, and that's because you can set the TRC value separately from the TRAS, but on Intel you can't, so your TRAS controls, like, because the Micron chips can't do low TRC, you need to run like TRAS appropriate for the TRC that you're trying to reach. Anyway, TWR12, cool. TRFC 540, yep, that makes sense for this speed. Then TRDs at 4.4, TFAW 16, WTRs at 4 and 2. Yeah, that's one thing where Micron actually has an edge over BDI, as far as I know, is that it can do like really low WTRLs. RTP6, cool. Right, we went over TFAW, TCWL 14, refresh interval 65,000, and then 6, 4, 6, 6, 11, 11, 11. Yeah, so this is dialed. Yeah, this is dialed in. Interesting that the right. Oh, yeah, that might make that might be the same thing as like how on Ryzen, the write to writes usually have to be slightly slower than the read to reads for dual rank. So. Yeah, cool. Cool setup. And also like good choice of memory sticks, because this is a daisy chain board, so yeah, you wouldn't really want to be running 4x8 on it. WRRDs 24 and 22. Yeah, Micron does really low, like is really good at like the write to read transition. That's like the one edge Micron memory chips have over B-die. Oh, VRAM stupid timing straps. If you have the timings decoded, you can just take a screenshot of them and submit them. And for reference, it would be good if you also posted a decoded stock strap for comparison, because like I've not looked at that many GDDR5 straps. Or like yeah. Anyway, let's go on to the next submission. I'm just grabbing a random one again. Oh, another 5800X 3D. Of course. So, on a Crosshair 8 Hero, with... Why such an expensive motherboard? And then such basic memory? Like, this is Hynix, isn't it? Yeah, that TRFC looks very Hynix. That I don't think, yeah. Your TRC could probably be a bit lower if this is Hynix. Anyway, 16, 19, 19, 19, 36, 58. Cool. TRDs 4 and 6, 16, 4, 12, 12, 497. This is dual rank, so yeah, you're... Like, I had to tighten up the dual rank timings from 5577 to 4466. And then other than that, I don't think there's really anything you can change about this, because it's Hynix, right? So, like, yeah, you could maybe try lower the SCLs. WTRL can probably go a bit lower. TWR probably can go a bit lower. But I don't think there's really anything else you can change. I mean, you could probably try lower TRC-DWR. That on most memory chips, that should be able to go down to 8. TRC is temp dependent on Hynix a bit. And yeah, TCL and TRP also. TRDs to 4.4. That's not, like, yeah, you could do that, but it's not going to drastically change the performance. And yeah, WTRS could probably go to 3. Tertiary's on auto. I mean, yeah, I mentioned the 5577 should be swapped to like 4466. Because this is a dual rank setup. Right. Yeah, you can see the mouse cursor. Anyway, so I'll just grab another random submission. Mostly because keeping like the other, I can't really, otherwise I can't keep track of chat at the same time. Okay, well, that didn't work. TWR to 10. Yep, that could also be an option for this. Like, the thing is, this isn't, like, super ridiculously tight, but it's also not so loose that, like, I think there's, like, massive improvements that could be made. Ooh, I grabbed a 2700X submission. So, let's take a look. Some Ryzen 2000 series. So we have a 2700X, ran 25 minutes of test mem5, so it won't immediately crash, but I don't consider that much of a stress test. And this is BDI at 3800. Damn. It is single rank. It is on an X570 Unify. So this has literally everything going for it, right? This is one of the best memory overclockers on the AM4 platform. As in, like, the motherboard is one of the best memory... Yeah. Actually, wait, no, that's the regular Unify, not the Unify X. Okay, so it's still a strong board. Not sure that... Nah, I'm pretty sure it's stronger than a lot of the earlier boards. Mostly because on the, like, X470 chipset, you didn't really have that many, like, 6-layer PCBs, period. Like, I think MSI had, like, 1. Gigabyte had, like, 1. Asus might have had a couple, just because Asus tends to... Or, Asus used to usually have a, like, higher layer count for their boards. Anyway, so yeah, we've got 3800, flat 14. So this is some good memory sticks. What voltage is this at? Even then, like, this is, like, even if it was at, like, 1.55, I would think good memory sticks. 1.5. Oh. So these are really good memory sticks. 53.3 proc ODT works better. Wait, whose is this? Oh, I took Strucken caps. Okay. Like, wait a minute. 53.3 works better. Yeah, that makes sense. I'm kind of surprised that you're at 60. Because, yeah, in my experience, 2000 series, it was always 53.3 worked best. Or there is no way this works at 1.45 unless, like, that would be, like, that would be some insanely good memory sticks if this worked at 1.45. So I'm going with 1.5. Oh, yeah, also gear down mode disabled. It's not even running, like, some insane amount of SoC voltage. Like, all of the timings are dialed, even the ones that don't do anything. Right? TRFC2, TRFC4. This looks like bench like for Ryzen 2000 series, this is what, like, I would expect bench settings to look like, basically. And it's like, nah, this actually runs like 25 minutes of some kind of version of testmem 5. So yeah, and solid latency. That's actually kind of fun because 2000 series was monolithic. When you go from 2000 to 3000 series, the latency actually got worse. I'm not sure if people remember that, but yeah, that was a thing. You go from 2000 series to 3000 series, and the memory latency got worse. And 1000 series to 2000 series latency got better because there was, like, optimizations to the memory architecture. Anyway, so we've got some more super chats in, and I'll take the first of those. Because the second one seems to be empty, which I'm hoping was... Oh, that was a mistake. Okay, okay. Why you gotta do this to me and make my life so difficult? I'm gonna open up both of them so that I don't lose the second one. Okay, so let's take a look at the first one, which is a 7950X, 8 hours of Karhu, and 6 hours of Y-Cruncher VT3. Okay, well, yeah, I would consider that very stable. Running at, at TJ Maxx because Y-Cruncher is very, very hot. And actually, this is one thing that I find really interesting is Y-Cruncher VT3 seems to be so transient in its loading that it sometimes manages to violate the TJ Maxx on AMD CPUs pretty consistently. Where it looks like the CPU temperature will actually end up going like a couple degrees over TJ Maxx. Because for a 7950X, it's supposed to be 95 degrees, but when you run Y-Cruncher, it'll actually hit like 99 and then come back down. So yeah, like the boost algorithm doesn't seem to be quite fast enough to keep up with the load changes of Y-Cruncher there. I'm not sure that it's actually a concern in any way. Like I would assume it's probably within tolerance. It's not what like Y-Cruncher is new. And in fact, AMD, like the developer of Y-Cruncher, like for 9000 series, he already had like a engineering sample CPU to optimize Y-Cruncher for 9000 series before launch. So, yeah, I would imagine AMD is fully aware of, the fact that like Y-Cruncher does these kinds of things. But it is like an interesting thing that like you can run basically any other test and it'll stay under the TJ Maxx or like at TJ Maxx where it's like just 95 degrees the entire time. And then you run Y-Cruncher and it actually manages to go over it a bit. Anyway, let's take a look at these timings. So we've got 6200, 30, 37, 37, 39, 30, 69. I'm hoping that your TRP isn't at 39 just for, nice. But yeah, I guess there are some kits that might not do low TRP. Though, if you're TRC limited, it's better to run loose TRAS and low TRP than it is to run loose TRP and low TRAS. Like, TRAS is less important from a performance perspective because TRP, you use that timing every time there's a pre-charge. It's TRP. Whereas TRAS is only relevant if you're doing a pre-charge really quickly after an activate command, which isn't super common. So what I would probably test with this setup is if you can run TRP 37 if your TRAS is like 40 or something. And I wouldn't even really bother changing to TRC to do that test. Yeah. Anyway, so TRD is 4820, cool. WTR is 416, cool. TWR 48, cool. TRFC 500, fine. SCL is 42, cool. RTP 22? What? Why? That could be 12. This is Hynix, isn't it? Yeah, this is Hynix. So, like, why is that not 12? I have no idea. TRDWR 16, okay. WRD 4, cool. And it is single rank, so we don't need to worry about the dual rank timings. Yeah, so that all looks good. It is very stable. So anyway, or like I consider this very stable. Right. I don't know. Somebody else might have different standards for what very stable is. So let's move on to the next submission. I keep building up tabs. Anyway, we've got a what is this? Oh, Maximus 10 Apex. Z39? No, wait. 9 was Z270. Z370 Apex. That's not a board you see very often. Even though I had a like wider that's not a board you see super often, even though it was actually like more widely available than the Z390 Apex, as far as I know. The Z390 one was better. Because the thing is, the Z370 Apex was basically a Z270 Apex with, like, to the point that you can put the Z370 Apex BIOS onto a Z270 Apex and it actually works. But yeah, basically they like upgraded the dual NFETs, and that was it, as far as I know. Like, there's very little difference between the two boards. Anyway, BDI at 4,000 running 14, 15, 15, yeah, 14, 15, 15, 29. That is an interesting choice of TRAS because the register limit on Intel is 28 and you're like one tick above it, or at least like according to the Intel documentation, the register limit is at 28 and you're one tick above it. But I've seen like world records for PyPrime and stuff running TRAS with like Intel CPUs running TRAS way below 28. And that seems to work. So I like maybe the Intel documentation just like isn't complete about that, or like, yeah, I don't get why it would say that like, oh, you can't set this below 28, and then actually it's like, no, you can. But yeah, like the Intel documentation for this is a 9900K, I'm guessing. Yep, 9900K. The Intel documentation for like 9th gen says that TRAS doesn't go below 28. Actually, I think for 9th gen it is enforced. It might be 11th gen where you can set it like stupid low, even though 11th gen still says that you can't set it below 28. Anyway, so that doesn't really matter. Like setting it from 29 to 28 isn't really going to change performance at all. So just interesting that it isn't 28 to me. Command rate 2T. Is this not single rank? Why would you be a 2T? It is single rank. So why 2T? You should be able to do 1T with single rank on an Apex. I'm pretty sure that should be doable. Like, I don't think, yeah, with the Apex, I don't think, like, if you can't do 1T at 4,000, you should be able to do it at 3,800, and that I don't think is enough of a frequency penalty to offset the benefits of 1T on an Intel CPU. And then also, well, we can't see the RTLs, but whatever. So yeah, so 2T and then 260, so that's good. 65,000 refresh interval, cool. TWR 15, could be lower. RTP6, cool. TFall 16. The thing with TWR is you have to set it through like the TWR pre-register. I'm not sure if, or well, you don't have to set it through that if you're on an Asus board, but like that's the actual register that controls that value, not, you know, like the TWR isn't actually a thing on the Intel CPU itself. Anyway, TFall, so like TWR is like calculated from the TWR pre-timing, not like it isn't like you ask the CPU what TWR is, you ask it what the TWR pre is, and then I think like cast write latency gets subtracted from that, and then like 8 or something, and that gives you TWR. Something like that. Which is also why TWR, if you check it with like ASRock timing configurator and memtweak it, they both read out different values for TWR because they both use different equations for calculating it, which is just amazing. Anyway, RTP6, cool. TFall 16, TCK4, TCWL 13, all good. Then for the tertiaries, we have 7, 4, 10, 12, 7, 4, 28, 24. Yeah, that looks good. Yep, that all looks good. Like the main thing I'm surprised about is the 2T. I would have figured an Apex would do 1. 1T doesn't boot. Huh. Oh, there's a set, the Maximus tweak. There's like a Maximus tweak thing. You might want to have to play with that. In the memory timing settings, there's like a Maximus tweak option. Play with that. And I think one of the settings is like better for 1T command rate working. Z390 Hero? No, that's just better than the Z370 Hero. Anyway, a bunch of other super chats came in, so I'm going to move on to those at this point. Yep. Oh, we have another 7800X3D at DDR5 8000. Another Gene as well. Oh man, this is slammed. 8034. This is going to be some high memory voltages. This is going to be like 1.6 or something, isn't it? On the VDD. And yeah, VDD IO at 1.44. But yeah, 8034, 45, 45, 38, 42, TRC 80. Yeah, this is absolutely slammed. 6624. So I heard that apparently 6624 is like better in 2-to-1 mode than like trying to do 4416 or like 4420. I haven't tested that myself yet. Oh, it's 1.54 VDD. These are good sticks. Yeah, good sticks. So yeah, so that makes sense. I haven't tested that myself, but like I'd believe it. The like memory controllers sometimes do strange things. So yeah, we went over that. WTR is 416, TWR 48, TRFC 480, cool. And then you have the other two that aren't used: minimized SCLs at 88, cool. RTP 12, TRDWR 16, and WRD 2. And it's a single rank setup, so we don't have to worry about the multi-rank timings, and TREFI completely maxed out. And FCLK at 2200. Yeah, so this is just an absolutely like maxed out DDR5 8000 setup for a 7800X3D. And it's on 16 gig DIMMs. Well, yeah, that makes sense, because otherwise your TRFC would be a lot looser than it is. As well as like your TRCD would probably be looser. And you'd need more voltage for TCL34 if I'm not mistaken. But yeah, this looks really good. So let's move on to the next super chat. First, full primary, secondary, and tertiary timing overclock. Rock solid, but any suggestions are appreciated. Well, let's take a look at it. B550 Extreme 4, 32 gigs of memory. Is this a 4? Oh, it's a 4x8 setup. The ASRock B550 Extreme 4 is like really good. And I'm basing that off of the fact that I have a Steel Legend, which is the same board, but with a different like color scheme. So there's no reason to be running it at 3600. You could be like, not all CPUs will do 3800 without complaining because of like 1900 FCLK not always working. But I would definitely look into getting this running at like 3666 or 3733 because Ryzen, like 7000 series isn't as sensitive to the Infinity Fabric speed as 5000 series was. But yeah, on 5000 series, like any amount of FCLK is worth more than any of the memory timings. You just want, as like priority number one is basically FCLK and then worry about the timings. Unless you're like sacrificing timings to the point that they're absolutely atrocious, but that's not going to happen. Yeah, so I would basically like that would be my first critique is like why is this not at least like 3733 instead of 3600 because like 3733 should basically always work. But in terms of the actual timings, well, 14.8, 14.12, 22.36, that's all good. Though 12 and 22 add up to 34, not 36, though I'm assuming you started with TRP 14 and then just forgot to adjust TRC down at some point. Not that it'll make a massive difference in terms of performance, but, you know, it's just like things. TRDS and TRDL 4.4, TFAW 16 good, WTRs at 4 and 8, cool, TWR 10 cool, TRFC 252 cool, SCLs at 2.2, yep, that's good, RTP at 6, nice, TRDWR 8 and WRD 3. Yeah, so this all looks good, and then also the dual rank timings are 4.4.6.6, so that's all good. Yeah, so good job on the timings, and now I would basically, I mean, I think if you want to just push the frequency up, you just have to loosen out the primaries. And the lazy way of doing that would be just, I would just go to like 15. Oh, wait, you can't do that. Wait, no, you don't have gear down mode turned on, and you're at 1T. You got that working? Nice. Yeah, so you have the setup there at 56. Yeah, but basically, so since you don't have gear down mode turned on, yeah, I would just set TCL to 15, TRCD to 15, TRP to 14, just in case. and then set it to 3733, and I honestly wouldn't be surprised if that was actually stable. Interesting configuration on the terminations though. 633. I think usually it's like 7 for the first one. But, you know, that varies by motherboard. And I don't think I ever ran, or like, I never tried to stabilize a 4x8 setup on my B550 Steel Legend. I did run a 4x8 4000 CL14 setup just for benching, though. Right? Like, I was just trying to see how far the board could take a 4x8 setup. And yeah, actually, I think I had it past 4000. Like, it wasn't stable at all because I was running like 2000 FCLK, right? So the stability was atrocious. Like, the Infinity fabric was just spewing errors at that point, but for certain benchmarks, it was viable. Um, so yeah, good timings, and then like I would just really try to get get the frequency up with this. That's I think the biggest improvement this could have done to it. Um, Oh no. I've tried scrolling down and things just okay, I got a bit lost, but next super chat. So, a laptop? Oh no. Not really overclocking, but whatever, that's fine. Create 64 gig Hynix A die. JDEC 1.1. SODIMM timings adjust with super locked down. Laptop, yeah, can only adjust timings with some wacky software. That exposes the AMD overclocking menu in the laptop BIOSes. Changing TRFC does nothing and TREFI is missing. Aww. Wait. If changing TRFC does nothing, then that might mean the system is using TRFC2 and same bank in that case. If you can set TRFC to like 50, um, unless you mean changing it in the BIOS doesn't actually apply. Yeah, well, these are SODIMMs, so that should be just, yeah, that shouldn't be using like LPDDR, which, anyway. Um, so wait, this is running 5600? Well, UCLK is at 2800, so yeah, it's at 5600. 34, 35, 35, and this is at 1.1 volts, so 28, 40, 68, 4, 8, 20, 7, 16. Interesting that at 1.1 volts you can't run WTRS lower. TWR 48. Okay, so that's as good as you can do there, I guess. And SCL's at 4 and 5. Do you just like not have access to write, or does it actually require a 5? Because that is super weird. Like, so often you can set that one to 1, and then here you can't. I guess, well, actually, right, this is an APU, so that is a different memory controller. So that might make a difference. RTP12, TRDWR20. I would imagine this should be able to go lower. Also, this is a 64 gigs, so like 8.8 on the... Do you not have access to the dual rank timings? 1010, like, I think that's JDEC, isn't it? Because this... No, I'm not sure. But yeah, I'd try to lower those. Like, I can't imagine, like, even if you're at 1.1 volts, I can't see a reason that you wouldn't be able to run them at, like, 8.8 or something. Yeah. SDDD is not JDEC. Do not want to go below 10. Huh. I guess those do scale with voltage then. Or it's some like weirdness with SODIMMs or something. Because I would have figured like, yeah, I would have assumed that those don't really like it doesn't really matter what your voltage is for those two. I don't like the thing is I don't usually run RAM at low voltages, so I just kind of don't know what happens at 1.1 volts most of the time. But I would have imagined that these would not be affected by the memory voltage. And at such a low speed, you could run them lower. But yeah, if you can't, then you can't. So anyway, next submission. I have a 1700X3D on a B650 Tomahawk. At 6,000. 1.1 SoC. Oh, so you're just like not... Like this CPU probably won't do 6400 looking at that SoC voltage, but like it would probably do... Okay, that was pointless. I would imagine it would probably do 6200 at like 1.25. Anyway, if I remember correctly, this mentioned something about unsure what to do to get RDRDSCL to 4. So I have heard that sometimes you get sticks where RDRDSCL just doesn't go lower than 5. Like, I think I know somebody who has, like, a kit that it doesn't go below 6, and it also scales negatively with voltage, so it gets worse if they run really high memory voltage. And it, like, at 6,000 they can run 4, but, like, at 6,200 it's, like, stuck at 6 or something, so... I guess maybe you could try lower memory voltage and see if that doesn't, like, make RDRDSCL work at 4, but... yeah, like, this might just be a limitation of the kit, and if it is just a limitation of the kit, I wouldn't worry about it too much. Like, it's not a big deal if one of your timings is 1 tick higher or lower, generally speaking. So, yeah, if it doesn't go below 5, then I would just not try to push it below 5, and I would try to get 6200 working, because if you can, like, if you can run 6200 and it's still 5, that's just better than if you're at 6000 and it's at 5, right? And anyway, let's go through the other timing. So CL28, so yeah, 1.45 VDD. How is that reading out correctly? Is this some newer version of Zen timings that, like, works with high voltages? Because you shouldn't be able to get a correct voltage reading for 1.45 volts. At least not on the versions I've used. But yeah, so 28, 36, 36, 28, 30 to 68. So this is a strong kit of 8i that you can run TRP at 28. Because that doesn't always work at low-ish voltage. Like, that, yeah, that's a relatively low voltage in my opinion. TRC at 68, I would try to lower that TRC. Yeah, I would definitely try to lower that TRC. And then TRD's 4, 6, 20, cool. WTR 6, 16, cool. TWR 48, cool. TRFC 390, cool. We already went over the SCLs. RTP 12, TRDWR 16. WRD1, yep, that, like, yeah, that just works sometimes. It's kind of the same situation as the right to write SCL sometimes do it working at, like, actually, I don't think I've run into a system where it doesn't work at 1. Whereas WRD, like, sometimes you can set it too low if I'm not mistaken. But a lot of the, like, sometimes it does work at 1, so, yeah. And TREFI at a completely random number of 55,067. Which is, like, more stable than if it was just set to 60,000 or 55,000 or 65,000, I guess. Not that that would make much of a difference. I guess if your memory sticks are running really hot or something, then having a slightly lower TREFI helps with maintaining stability at high temperatures. Yeah. So this looks fine, and I'm gonna guess, like, the SCL not going below 5 is like it could be a voltage thing. But it could also just, like, be these memory sticks don't want to go below 5. That's not impossible, it's just uncommon. Oh, we've got RTLs for that Apex system. I mean, I was just wondering if they're, like, also, wait, did you, okay. Well, let's take a look. Oh, those look good. Yeah, 55, 56, 77, that looks good. So it's not doing anything wacky. With that, like, I was mainly wondering if they were, like, at, like, like, if your IOLs were at, like, 13 or 11 or something. Because that does sometimes happen once you go above, like, 3800 on some boards. That, yeah, your IOLs and RTLs just get horrendous. And if that was happening at 4000, then it would have really made, like, to me, it would have made a lot of sense to try go down to like 3800 1T with good RTLs rather than 4000 2T and messed up RTLs that admittedly you could probably manually fix, but, you know, that could get kind of involved. But yeah, this looks fine. Like, I don't, like, to me, those RTLs look fine. Like, I'm not the best at dealing with RTL timings on Intel systems, but I don't see anything immediately wrong with that. And we got another super chat, so I'll take a look at that. What about voltages then? Oh, voltages. DRAM at 1.57. Where's system agent? VCCSA at 1.27. Yeah, that's fine. It's on the low end of system agent voltages for Intel CPUs, and I/O at 1.28. Yeah, that all looks good. Yeah, I don't see anything worth complaining about. 1.4 on the CPU, it's a 9th gen, so I don't see any reason to be worried about that. So anyway, next super chat. And then I think that'll be the last submission. I might do one more after this, and that'll be the end of the stream, because, yeah, it's been almost 2 hours at this point, so let's take a look at this. A i5-13500 at 3200. Is this RAM just trash, or €60 MSI 2 dimmer? 3200 max chipset limit. Oh, it's a H610. Oh. I didn't even know they did that. Random OEM green stick Hynix DJR. Primaries will not go any lower at this voltage. Yep, that sounds like Hynix. Actually, what voltage? DRAM at 1.47. Oh man, these sticks suck. If they don't go like 3200 at 16 at 1.5 volts on, like, almost, yeah, you're almost at 1.5 volts on the memory, and they don't go below 16 TCL. These sticks really suck. 16, 17, 17, 28, 1T. At least it's 1-to-1 mode. TWR is good. Refresh cycle's good. TRD LNS good. WTR is good. Yeah, because like 30, 24. I would have imagined at this speed you could probably try to run them a bit lower than that, but yeah. Anyway, 4, 8, 16, 14. RTLs look fine. I mean, yeah, they look fine to me. And then refresh interval at 55,555. Okay, that makes sense if you just hold down the 5 key. Yeah, I don't really have any. I mean, I think the SG timing could be lower than 8. I think. Yeah, but like this is a single rank setup, so like SG, like read to read SG and write to write SG, I would try to lower those. But other than that, I can't think of anything else to change. 2500% MemTest Pro, no errors. Cool. Yeah. I mean, I can't say it looks good because it's not, but like there's also not really anything like if this is like I don't see anything where it's like, oh, I mean, other than the SG timings, I tried to lower those because they might do like 7 or 6 and that should be a bit faster. Anyway, so I'll take the next super chat. And we actually still looks like we'll have time for one more submission. Unless I take forever with this super chat. So we've got a 7950X3D on an X670 EA Aorus Master running 7800. Synced FCLK and UCLK. Wait, so you can do that on Gigabyte boards. I've not managed to get that to work on a Gigabyte board. Like for some reason, at 7800 and 7600 for that matter, because I don't think there's like a 1900 ratio that's easily accessible. Like the board, like for me, the boards just default to 2000 FCLK, and I haven't figured out how to get them to not do that. Unlike MSI and ASRock, if you leave the FCLK setting on auto and you're at 7800, it'll automatically go to 1950, and you get like a synchronization benefit from that. But yeah, I haven't figured out how to do that on Gigabyte, and evidently it's a skill issue on my part. So that's great to find out. Anyway, looking at the timings, is there anything really stupid? I mean, 36, 47, 47, 46, 44, 90. Nope, that all looks good. What is this? 24 gig DIMMs. Yeah, so that all looks good. 8, 12, 32. Yep, that makes sense. 420, cool. TWR 48, cool. TRFC 658. Yep, that makes sense. SCL's at 88, cool. RTP 12, TRDWR 16, and WRD 2. Cool. Yeah, no, I don't see anything wrong with this. Also, man, that is a very low SoC voltage, but that makes sense because you're like that's the thing is like in 1-to-1 mode you run really high SoC voltage because you need it to get high UCLK to work. But when you're in 2-to-1 mode, your UCLK is so low that you can run very low SoC voltages. I guess one benefit to running 2-to-1 mode is that your idle power consumption is lower because your SoC voltage is so much lower than 1-to-1 mode. Especially if you're running 1-to-1 mode with like very high SoC voltage compared to 2-to-1 mode. Yeah, so this is cool. Like this is a cool setup in terms of just like the voltages that you're running here. Then VDDIO at 1.38, VDDQ 1.38, MVDD at 1.43. Yeah, this looks good. Cool. So AMD CBS menu or PBS. Yeah, I know. I went into the like hidden menus and everything. Like I set the FCLK in the main overclocking menu to auto, and then I went digging through the AMD like overclock AMD's menus, and there's like a FCLK setting, and I set it to 1950, and then I boot the system, and I open up Zen timings, and it's 2000. And then I go back into the BIOS and I see that the BIOS automatically set the option in the main menu, like in the tuning menu, to 2000. And so I set it back to auto or something, and then I reboot and it resets itself to 2000. And it's just like, I didn't find a way to get it to set anything other than 2000 if it's on auto. And if it's not on auto, it's whatever it isn't. Like because that main option for setting FCLK goes 1800, 2000, and then like above that, like there's just this massive gap between 1800 and 2000 where it's just like, where did those go? I don't know. And they're like, I found the other option that has the 1950 ratio, but like for whatever reason I couldn't get it to apply. F32A has new FCLK options. Oh, okay, that explains it. Yeah, I haven't checked the newest. Well, like my daily system is probably pretty up to date, but I haven't checked like the no, I'm on like F31 or something, I think. But yeah, like my daily system, I haven't like tried to do 2-to-1 mode, and I haven't checked the other Gigabyte boards I have in a while. Like I don't enjoy memory overclocking enough to check if every BIOS version has made any major differences. The AMD overclocking section. So the thing is, you're not really supposed to be using that section of the BIOS. Like straight up, you're not really supposed to be accessing it. The way it's supposed to work is that that section is in the BIOS, and the motherboard vendors are supposed to like link their stuff to that. And anything that they don't look at, like they're basically the BIOS like re-implements the AMD overclocking section in a way that is like safer is the idea or something like that. So yeah, the fact that like if you go into that section and stuff breaks, that's like, yeah, that's kind of expected behavior, unfortunately. Ryzen Master. Yeah, and this is why we don't use Ryzen Master for setting things. Like, OS level tuning tools are bad for CPU overclocking. Like I use like the only things I've ever changed in Ryzen Master are like core voltage, core ratios, and that's it. And I generally don't install it on a like I wouldn't put Ryzen Master on my daily system. Just straight up, that is I would not put it on my daily system. Like I've used it on test benches because your alternatives for getting control over core ratio are awful for AMD systems. Um but yeah, like there isn't like I'm not aware of like an AM5 Turbo V Core or something. Um So anyway, we'll do one more submission, and I think that'll be it for this stream. Oh, another 5800X3D. Imagine my lack of surprise. Oh, and it's running B. Oh, actually, this is slammed. And these sticks are pretty good. Yeah, these are like nice sticks. Oh, it's a 4400 CL17 bin. Okay, that explains it. Man, I wish I had one of those kits. Or like several of them. I don't have a lot of dual rank B die, unfortunately. I have like, or I don't have a lot of good dual rank B die. I have like I think I have like two 3600 CL14 kits, and that's it. No, I have a 3600 CL14 G scale, and I have a 3466 CL16 Corsair. And I think that's all the dual rank B die I have, which is kind of lame. What, didn't you get a 4800 B die? What? No. No, I didn't. I have a 4000 CL14 kit from G-Skill. But yeah, I don't have a 4800. You turned into a metal guy? I've always been into metal. No, like the highest rated B-die sticks I have are 4400 CL19 in terms of speed. And then the highest silicon quality I have is 4000 CL14. Yeah, I have some Royal Elites in 4000 CL14. Anyway, let's go through these timings. So we've got 3800, 14, 8, 13, 13, 21, 34. Yeah, so these primaries are absolutely insane. And it makes sense for a speed bin of 4417. 1.52 volts. Like, it's not even crazy voltages or anything. Like, these sticks are just that good. TRDS and L at 4416. Yeah, TFall 16, so that's all good. WTR is 48, cool. TWR 10, cool. TRFC 260, nice. SCL's at 22, nice. TCWL 12, yep. And RTP 8, cool. TRDWR 8, WRD 1, and the dual rank timings tightened up. Interesting that your drive strengths are all set to 20. I don't think that I've ever seen anybody else do that. What board is this? It's an X570 Unify X. Oh, it's the new Unify X. Cool. Oh right, X570S Unify X, yeah, because there's also the B550 Unify X. Yeah, so this is just like absolutely slammed on the timings. I wish I had a dual rank kit with like that was the thing is when I was requesting the sample from G-Skill for the dual rank kit, like the 3600 CL14 I went for it because at the time it was like not insanely expensive. Yeah, like as much as I'm a fan of the ridiculous like high-end memory kits, is like I don't like they're awkward they're awkward to make content about in my opinion because like I would never actually recommend somebody buy one of them. Right? So it's like, "Oh, look at this really really like it is overpriced as far as I'm concerned." Or like I guess it depends on how you look at it. Well, no, I wouldn't buy it. That's the issue. Is like, yeah, it's cool that I can request it as a review sample, but if I actually had to buy it, I'd never do that. right? Like the only way, yeah, like basically the only way I'd end up with one of those like Uber bin memory kits is if I find one getting sold for a low price on eBay. Because I'm not paying because yeah, like yeah, you can get BDI in like, speed bins that are just insane, and the price reflects the like speed bin, right? Like I'm not saying like, oh, it should like it's just not cost effective. So it's like I wouldn't buy that even though I think it's cool. So I don't like that. That's the thing is like when I usually like ask for review samples, I try to ask for like reasonable spec stuff that I would actually consider purchasing, right? Actually, that's basically literally what I do is like I go like, man, I want a memory kit that does X. And then I go look at like PC Part Picker, right? Sort lowest price to highest until I find what I want. Actually, no, I usually sort highest price to lowest because if you go the other way around for memory kits, the bottom end is trash. Like we can just skip that, right? And there's not that much high-end memory that you would get like lost in the high-end section of the low, like from highest to lowest. So you start highest to lowest, and then you just, like you set your upper limit for price and then start looking around. Um, and yeah, and then I'll like find something that I'm like, oh, this is like something I would actually consider buying. And if it's made by a manufacturer where I can like email them and go like, hey, would you send me a review sample of this? I'll send them an email of like, hey, would you send me a review sample of this? And that's how I don't end up with review samples of like ridiculously high-end memory kits. Um, so yeah. And that's like, man, and it annoys me that like my dual rank BDI memory sticks are all just kind of like they're not terrible, but I don't have anything that's like really really good, and I don't even have like 4 matching sticks. That annoys me more that I don't even have like 4 matched dual rank sticks. Um, so yeah. Why didn't I place myself in over here? Good question. See, I am bad at like making videos. I don't know if you've noticed, but I'm very bad at making videos. And so like this is like the default. Actually, yeah, I just like copied this position from like other streamers. Like other streamers always, go here. Like the StarCraft 2 streamer that I watch, like he's in the bottom right corner. Yeah, like all the like I can't think of any streamers that I've seen that aren't in the bottom right corner, so logically I should be in the bottom right corner instead of over here. Yeah, I guess I could fill out the space more. There. Um I guess I should at this point just make this like a separate setup for the OBS. So anyway, that'll be it for this stream. Because yeah, it's been 2 hours. Big thanks to all the people who super chatted. Hopefully you found this somewhat interesting or useful or something. And yeah, there will be another one of these next Sunday. Probably at a slightly different time. Should it be earlier or later? I'm wondering, just like chat, like earlier or later. You should request a review sample of the new DDR5 Trident Royals to see if they have thermal pads on the PMIC. I don't want to, yeah, but I need to make a video about it then. And that's like the issue is like it's like, oh, it's not just request a review sample, get the thing, and it's like, okay, I need to make a video about it. And I don't, like I don't enjoy like I don't want to have to like overclock RAM again. Bit earlier, please. Okay, sure. Like, yeah, so I'll move it back like a few hours. It's 3 a.m. in EU. Yeah, okay, earlier. How do you know you'll not be asleep a week in advance? I mean, I'm usually awake at around midnight. So, 3 hours before midnight or 3 hours after midnight, what's the difference? Kind of the same. Um, so yeah. Um, yeah, I don't really feel like testing any more RAM right now. And actually, the thing I'd be most interested in testing is like team group memory sticks right now. Like if I was going to test more RAM, it would probably be team group because I don't have any team group DDR5 at all. Like all of my DDR5 is like G-Skill and Corsair right now and like some Gigabyte sticks. Um so is this the end? Yeah, it is the end. So do you RAM? No, I am not going to tune your RAM for you. Did you get into timings for benchmarks or gaming? For benchmarks. It just so happens that it also helps gaming performance, but that was never why I bothered. Like, I got into memory tuning basically for benchmarks. Team Group Delta 7200 3442 kit is magic for running DDR5 8000. Yeah, see, that's the kind of stuff I keep hearing about the Team Group sticks, but I don't have any, and I don't really, like, I mean, I could buy some, I guess. Or even like send an email to team group, but then it's like they're gonna want like, oh, what content are you gonna make with it? And it's just like, man. Or is it memory sticks? Ah, the website layout is all messed up because like my browser is like squashed to the side. Oh, the 7200 CL34 isn't that bad. It's like 130 quid. No, I already got sent some like green sticks, unless those are like other green sticks, and I haven't even tested them because like that's roughly how interested I am in memory overclocking. Wait, this is just 8i green stick, isn't it? Wait, what? Why is this 4? Is that not the right part number? Wait, Sebi, why are you posting freaking X16 chips? Am I stupid? Or is this website stupid? Do they just have like the wrong picture of the memory stick? Because this looks like X16. Oh no, it is X8. Oh yeah, so their picture's just wrong. Um, yeah, I have 8i green sticks already. I haven't even like, I don't think I even turned them on. So yeah, that's kind of that. Like I've mainly been, well, not really messing with hardware for the last week. Mostly been like messing with the game that I'm developing. Um, your YouTube channel is becoming very large. I don't really feel like that. I feel like my channel just kind of oscillates around the same size for a while now. Say dailying 1.55 on BDI, DDR4? Yeah, I wouldn't really worry about that. As long as you have, like, the main concern with higher voltages on Samsung 8 gigabit BDI DDR4 is that at higher voltages, it runs hotter and it's temperature sensitive. So if you don't have enough cooling and you try to run, say, 1.6 volts, it's not going to break the memory sticks, it's just going to crash if the temperature gets too high, right? So you'll be like if you stress test without any GPU load, and then you go play a game, and you have bad memory cooling, and you have like a 4090, and your ambient case temperature goes to like 40 degrees, your memory sticks will be at like 60, and they will blue screen the system. Actually, they might not blue screen the system, but they'll like crash the system probably. Um, so Yeah, so with the voltage, like I've never like I've heard of B-die sticks up and dying for no reason. That's like a thing. I suspect it's usually related to people pulling them in and out of memory slots. Um, but I've never heard of somebody having like a B-die stick die while in a system at high voltage. I don't think I've ever heard of that. I have heard of like, oh, I've actually had that happen to me where I had like a B-die kit that was sitting on a shelf, and then one day I'm like, yeah, I'm gonna run it, and then I didn't get to run it because one of the sticks died. Um, but yeah, I've never had I've never had a stick of B-die die, and I've regularly run mine above like 1.8 volts. Um, not for like daily use, but like for benching, and yeah, it's just like never been a concern. Is like they don't degrade, they just don't like running at high temperatures, so you need a fan over them at those kinds of voltages. Um, so yeah. Anyway, um, that's that. So yeah, thank you for watching. And yeah, there will be another stream next Sunday. Hopefully, a few hours or starting a few hours earlier. Actually, one of the issues with this was like I actually went like shopping. So that's the main reason this got delayed. um, so anyway, yeah, that's it. So thanks for watching, and goodbye.